This is my first video in my module on finding the areas of triangles, and what I mean by area of triangles is necessarily non-right triangles. Okay, so it is the case that when you do find the area of a triangle, as a matter of fact, any triangle, let's say we do have a right triangle case, that you would have some sort of altitude or the height, and you'd have the base, and we could say the area is 1/2 the base times the height. And it doesn't actually have to be a right triangle. It could be some maybe obtuse triangle such as this, but the bottom line is you'd have to have a base still, and you'd still have to have an altitude. So if we were to extend this side, you'd have to know the height of this triangle or the altitude. The cases that we're going to explore in this module essentially have triangles in which we are not familiar with the height of the triangle, and we don't want to solve for it. And there are some nifty ways to do so. So in this first video, a few things I want to point out. First of all, we use the capital letter S in all of our formulas today to denote the area of the triangle, since if we were to use like the capital letter A, we might think that that would be easily confused with, say, vertex A. Okay. So the case we're going to start with in this first video is our side angle side case. Okay, so that would be a triangle in which we know a side length, we know another side length, and we know their included angle. Okay, so this is very, very important. But when we know two sides of a triangle and their included angle, what we mean by this is given any triangle, if I were to draw just, essentially this triangle right here, we would say it'd be known here, known, known, two known sides, but then we would have to have their included angle, and their included angle just simply means the angle that is listed between them. So when we say side angle side, it must be in that order. But if that's the case, if you had two known sides and a known angle that is included between them, then we could use one of these three formulas that you see here. And so, an important thing to do is remember how to memorize these, okay? So as far as finding the area goes, I mean, honestly, to put it very bluntly, it's just the product of 1/2 on all of these times the two known sides and the sine of their included angle. So AC sine B, BC sine A, AB sine C. But you'll notice that if the two sides you know are A and C, you'll notice that the angle included is actually going to be capital B. So you cover all three letters of your triangle. You got AC and B, or side BC would be times sine of A, or their included angle. And it'll become fairly obvious when we actually sketch out the triangle that that's always the included angle. If the side lengths are say A and B, then the included angle would be sine vertex C, and they're all multiplied by 1/2. Okay, so this is like the easiest of our three formulas here. So what I'd like to do is use this example down here where I want to find the area of the triangle with this given information. Okay, so let's say we had a triangle with vertex A being 35.1 degrees. What we need to do first of all is sketch this triangle. Now, it does not need to be drawn to scale. However, when we do label out all the sides on this one, it's kind of an appropriate thing to do. And it's 35.1 degrees. I apologize for that. But we'll call A the smallest angle. It seems to me that a 35.1 degree angle is not very large. So we have 35.1 degrees. Okay, if that's capital A, however, then this is going to be lowercase a, side opposite. All right. Also, this we tend to call the largest angle C. It doesn't have to be that way, but this would be lowercase c across from it, and therefore this would be capital B, and of course lowercase b across from it. We're given the fact that B is 2.43 centimeters, so 2.43 cm, and also that lowercase c is 3.57 centimeters. So of course recall that we are seeking to find the area of this triangle. That would be the amount of two-dimensional space that this thing occupies. And in this instance, we are not familiar with the height of this triangle. And so since we don't know this, we can't just do 1/2 base times height. What we need to do instead is use these formulas that I've got listed here. So in terms of which one we're actually going to use, we say S equals. It doesn't really matter which one we use, because recall we said it's really just the product of the two sides with the 1/2 and then times the sine of their included angle. As a matter of fact, if you knew that this was a side angle side case just by looking at this, you wouldn't even necessarily need to draw the triangle. You could just say, well, let's just insert the values here. But in this case, I do want to note that we would be using the case in which we have two sides, B and C, and then this would be the sine of capital A. Always good to label your sides. So here we have this. We say 2.43, and then we have 3.57 here, and this is the sine of 35.1, and this is in degrees. You need to make sure your calculator is in degrees. Right now, if you were to leave it this way, this would be the exact value of it with the given amounts that we have here. But we actually do want to multiply this out and get a value for S, or area, which is going to be an approximate value because we're going to round. Another really quick thing I want to mention before we go ahead and multiply this out and be done with this video is this. we're taking centimeters times centimeters, which we have to realize produces centimeters squared. This is important because we were seeking to find an area in the first place, and of course area is 2D, it's two-dimensional, has both a width and a length. Okay, so that being said, let's go ahead and get our calculators out here. I'll go ahead and get this guy. It says we're in degrees. This is good. I'll put this down here. We have 0.5, 0.5. Actually, let's do this first because the calculator is a little wacky. We'll do sine of 35.1. 35.1. I'll hit my sine key. So this is the sine of 35.1. We'll take that times 3.57 times 2.43, and then multiplied by the half we've got out in front, times a half. And so what we dig out here is essentially this. This triangle has an area of approximately 2.494 square units. So 2.494 centimeters squared. It is very important that you are labeling these with the appropriate units here. And also you'll notice that I went out one extra place value than the values that I was given. That is, our original values went out to the nearest hundredth, at least in terms of the side lengths. I went out one extra place value, so we rounded it off 2.494. And last but not least, is this reasonable? I don't know, it seems pretty reasonable to me. So this is just a very trivial case, the side angle side case. In the next video, we're going to talk about the angle side case. Cheers.